after the concept of series combination and parallel combination of resistor and the equation related with this, now we are able to solve some of the numerical problem which is related with series and parallel combination of resistor. That's why I am taking one numerical here, and while solving this numerical problem we would have a good knowledge about its theory also and its implementation to solve the numerical problem also. Look at this. Let's say these are the resistors and they are connected this way. Two resistors are seems to be connected with each other in parallel, but these are differently connected. Now let's say current is passed from this end and it reaches to this end. From this point suddenly current divides among these two branches and it flows this way and lastly comes out from this way. Now I want to find out the total resistance between these 2 points. Let's say A is a point, initial point, and B is another point. And this structure, I mean to say these resistors are connected with certain battery and current is made to flow. Now I am going to find out total potential difference between AB. Now, how to start? Looking at this diagram, what can I say? This and this, these two resistors are in parallel. Let's name them first. Let's say this is R1, this is R2, and this is R3, and this is R4. We can say let R1 equal to 5 ohm, R2 equal to 10 ohm, R3 equal to 15 ohm, and R4 equal to 20 ohm. Now to this, looking at this connection, we can say that these two R2 and R3 are connected in parallel. That's why I want to start from this. R2 and R3 are in parallel. Therefore, according to previous knowledge of parallel combination of resistor, the reciprocal of total resistance is equal to sum of the reciprocal of each resistance. I told you in previous class also. Now, let's say total resistance of these two is R', and the first one is R2, second one is R3. Now I can calculate the total resistance of these two R2 and R3. This is equal to 1 by R2 is 10 ohm and R3 is 15 ohm. That's why if we take the LCM of 10 and 15, we'll get 30. 5 2s are 10, 5 3s are 15, 5 2s are 10, 3s are 30. That's why LCM is 30, 10 3s are 30 plus 15 2s are, that's why 2 are the 2. This is equal to 5 by 30. 5 1s are 5, 5 6 are 30. Here 1 by R' is if equal to, we can say 1 by R' is if equal to 1 by 6, then R' is equal to 6 ohm. It means total resistance of these two is 6 ohm. But when we get total resistance of these two, then this one is connected in series with these two, R1 and R4. That's why we can say this way also now. R1, R' and R4 are in series. Therefore, total resistance R will be equal to R1 plus R' plus R4, because in series combination total resistance is equal to sum of the resistance of each resistor. That's why I am writing this way. This is equal to R1 is 5 ohm plus R' is just now calculated 6 ohm and R4 is 20 ohm. Now total is 6 plus 5, 11 plus 20. This is 31 ohm. Therefore total resistance is 31 ohm. This way we can solve numerical problem, but we have to keep in our mind that when resistors are connected in series, then the total resistance is equal to sum of the resistance of those resistors. But if they are connected in parallel, then the reciprocal of the total resistance is equal to sum of the reciprocal of the individual resistance. Looking at this numerical, at once we can say that these two are in parallel, but the total of these two is in series with this two. That's why we can solve this numerical problem very easily.